Okay, so my Math 8 students, my wonderful Math 8 students that keep showing up, one thing you need to know is that I am sending these to YouTube. You gotta wait for them to get to YouTube. If you can't watch them here, let me know. I will send them to YouTube a little bit quicker that way. Maybe, let's see what I can do with the time I have, right? Okay, so we're gonna go to page 113, 4.4, and what we're gonna be talking about for this lesson, 4.4, so we're going to be talking about proportional and non-proportional situations. Now, of course, if you look in the book at page 113, that'll tell you that. I'm going directly to your turn. And basically, your turn gives us two different models to look at. Number one, messy, so bear with me. Looks like this. I got that right? Yeah, number one looks like this. Number two, this is at the bottom of the page if you're just getting lost with me because you've not listened to everything I say or I haven't said it well. Number two, it looks a little bit different. Number two looks like this. Now, so what we need to understand, and we need to understand it, is we need to understand that proportional models always intercept x equals 0. So look at these two. One of them is proportional. The other one is not proportional. Non-proportional. And we started out with this weeks ago, guys. It's not something that's new. For it to be proportional, we have to have x equals 0. 1 or 2 has x equals 0. Starts or intercepts elsewhere. I happen to like that word for this use, so sorry if that's one you're not used to writing or used to seeing. So, which one of these intercepts 0? Well, 0, 0. 0, 0 is right there. So that's an intercept of 0, 0, right? If it had gone through, that would be even better. We'd see that. If it had gone from negative, negative, negative to positive, positive, that would have been great. This one, x is 0, this is 0, and y is 1. Does not. So it's non-proportional. Non-p and p. Easy peasy, lemon squeezy. That's not a real challenge. And once you've seen it, that should be gold to you. Now, so if I'm looking at an equation, and I'm trying to determine that, and now we're on page 114. I'm still looking at your turn at the bottom. The first one says d equals 65t. Sorry, 65t. Well, I don't have y equals mx plus b. So that must be 0, right? 0, 0 is part of this equation. So this is proportional. Now I want you to see something that strikes out here. And I'm going to say P or non-P for that. Right, number 2. Number 2, this is, sorry, let me erase this. I don't want to confuse you. This is the bottom of the page. This is number 5. This is number 6, bottom of the page. Number 6 says P equals 0.1 s. Right? I'm thinking that's got to be seconds. Could be, right? Plus 2,000. Well, I got a B here. That's my B. I got to go all the way up to 2,000 on it. And this, because it doesn't cross 0, 0, is not proportional. It's really that simple. Right now, 7's a little squirrely. And I say it's a little squirrely because 7 is n equals 450. What did I? 450 minus 3p. Now, the very first thing I want to do to make it look something like this, to look like y equals mx plus b, is I want to take this and add it to this as n equals negative 3p plus 450. Once I've done that, bingo, I'm solid as a rock when I say, yep, that's a multiplier of x plus an amount, or minus an amount, because we're adding the negatives. See that? See how that works? This makes an addition when I do that. So this is, because of this, non-proportional. And 8. 8, you should all know as soon as I put it up here. This is 0. There's nothing being added or subtracted from the multiplied value. Multiplied value, right? Multiplied value. Multiplied value. Multiplied value. Multiplied value. T is unknown. S is unknown. P is unknown. D is unknown. Okay, so got through that. You should be able to see this a little bit easier when you get to 115. Follow the examples. Make sure you learn the examples. And then, when you get to comparing proportional and non-proportional situations, the word problems become critical. You need to say, oh, can it ever be 0, 0 when I graph it? And you'll know if it's non-proportional or proportional. Okay. Example 4 is a little bit of a challenge. The guided practice should be okay. We're going to look at the origin to see if it's proportional. Okay? Have a great day. Good luck with that.